Who got it?
I did.
John, how'd you do it?
Okay, so 60 plus 40
60 plus 40.
is 100. And then you have the rest of the 80, so then it has to be 80. 4 times 2.
Okay, so if you added 80, it would be 180.
180.
But where are you getting this 40 from? You kind of pulled it out of nowhere.
Oh, you cancel out all the other ones. Like I plugged it in, and it didn't
Ah.
work, so then I just used that.
So do you guys hear what John's doing? He's using the answer choices to help him figure out the answer. So he's saying, okay, what if angle B was 40, right? Or no, what if angle C was 40? What's twice 40? 80. So if angle B was 40, then C would have to be, or if C was 40, B would have to be 80, right? And then it would all fit inside of a triangle because they would add up to 180. There is a surefire way if you weren't given answer choices to do this problem. Zach?
180 minus 60 and divide by 2.
Good. So you can take 180. You know that there's 60 degrees already being used, so you get 120, right? Why'd you divide it by 3 though, Zach?
Because there's 3 angles.
There's not 3 angles. There's 2 angles left, because one angle you already knew was 60, right?
Yeah.
Juliet, why do we divide by 3? The original angle, which is C, right? Let's make that x. And then the other one's twice whatever that one is, right? So 2x. If you add those together, how much do you have? 3x. So we know 3x must be 120. That's why we're dividing by 3 here, guys, okay? Because it's basically 3 parts. 2 times is going to be the C or the B value. And then 1 time is going to be the C value. So you divide by 3, x is going to be equal to 40 degrees. Okay? What I always do to solve these problems, guys, is I make one of my angles x. And in this case, you wanted to make C the value of x. You know that B is 2 times whatever C is, right? So what would B's value be? 2x. You can add them all together and set it equal to 180, and you could solve for the same thing, okay? Your answer should have been B. Any questions on the warm-up? Sienna? Learning about a specific shape called a parallelogram. Guess what word is in parallelogram? Parallel, okay? So draw this symbol again. A lot of you drew blanks and asked me on the test, hey, what does this symbol mean? I am not going to help you in the future, okay? This is a symbol, which means parallel, okay? It's 2 lines that will never intersect. Excellent. And they have the same slope. Okay, so if you're ever going to prove that something's a parallelogram, you just need to prove that it has the same slope, okay? So check it out. By definition, a parallelogram is a quadrilateral. What is a quadrilateral? 4 sides, okay? With 2 pairs of parallel sides. That's what makes a parallelogram. Pretty basic, right? To write the name of a parallelogram, you use a certain symbol. And that symbol looks like a, have you ever seen like in Word documents, you can like italicize something? It's like an italicized rectangle. So it's like a rectangle, but like slanted. Do you guys see that? That is the symbol that indicates it's a parallelogram. A better version is this one down below. That is the symbol that we use to call out a parallelogram. And a parallelogram has how many vertices? 4. So you're going to see 4 letters, for example, A, B, C, D, written after that parallelogram symbol. Okay? Now, if there's 2 sets of parallel sides, we now know that AB is going to be parallel to the side opposite it, which would be CD. And the same thing with BC and AD. Now, the confusing part about parallelograms is a lot of students believe that all 4 of the sides have to be the same length. And that is not true. Would you guys say that all 4 of these sides are the same length?
No.
Absolutely not. BC is much larger than AB is. Do you guys agree with that?
Yes.
So the only requirement for a parallelogram is it has 2 pairs of parallel sides. Okay? Now, when we're dealing with parallelograms, there's a lot of congruence that happens. Okay? The first piece of congruence is that opposite sides are congruent to each other. That is our first of 4 theorems in this lesson. Okay? Your first theorem is that opposite sides are congruent. So we can say that since BC and AD are opposite of each other, they have to be congruent, which leads me to the statement that BC and DA are congruent. So not only are they parallel, but they're also the same size. So if BC was 7, what would AD be? 7. Easy, right? Now, AB and CD do not have to be the same length. They don't have to be 7, right? Let's say AB was 3. AB has to be the same length as CD. So both of those have to be 3. Now, clearly, BC is larger, right? And only the side that's opposite it has to be congruent. The other two sides can be whatever they want, but those two also have to be congruent. In what kind of shape are we talking about? Parallelograms, okay? The second theorem that arises when we're talking about parallelograms is the opposite angles theorem. That says that any angle that's opposite has to be congruent, has to be the same measure. So in this figure, do you guys agree that the two blue angles are opposite each other? And do you guys agree that those appear to be larger than 90 degrees? They appear to be obtuse? Pick any obtuse angle, Kristen. 270? Well, that would be very, very large. Between 90 and 180. 120. What would angle D have to be? 120. And let's just say hypothetically that C was 60 degrees. What would A have to be? 60 degrees, okay? Hannah, what's up? As long as, so do you agree that like 90 would be right here? This would form a 90 degrees. Do you see how it's like extending larger than 90 degrees? It opens up wider?
Not necessarily.
Not necessarily? Why not?
Because it depends on the size of the diagram or how big you draw it.
Well, actually, angles don't matter the size. So I can do this. This angle, right, is the exact same size as this angle. It doesn't matter how big I draw the angle. It matters how wide it's opening. Does that make sense? So these would both be 90, but this one's clearly obtuse because it opens larger than 90 degrees. Does that make more sense? Okay? So always look at the size of the angle. In other words, like this one is clearly what? Acute, right? Because it's not forming a 90 degree angle. It's smaller than that. Does that make more sense?
Yeah.
So like you can look at C and be like, oh, that's a much smaller angle than angle B is. Okay? Good questions. Any other questions about opposite sides, opposite angles? Next two theorems. There's 4 in total, so these are the last 2. Whoever's making the Quizlet, okay? This is where you're going to generate 4 of your new Quizlets, okay? Your new flashcards. This third theorem is the consecutive angles theorem. Now, guys, consecutive means next to, okay? Or like adjacent, right? It's in order, it's in line, it's going from one to the next one, okay? So consecutive angles must be supplementary in parallelograms. What does supplementary mean? They add to 180 degrees. So adding 2 angles that are next to each other must sum to 180 degrees. So let's focus on angle B. Angle B plus what angle will add to 180 degrees? Angle B plus angle C. Very good. Angle B plus what other angle will add up to 180 degrees? A. Now, angle B and angle D, will those add up to 180? No, because they're across from each other. Do you guys see that? They're not next to each other. This is talking about consecutive, which means next to. So the angles next to each other must add up to 180 degrees. Now it works because didn't we say that A and C would both add with B to 180? A and C are the same amount, right? So that makes sense for us because they would be supplementary with both of them. Okay, and then the last theorem in regards to parallelograms is about their diagonals. Who remembers what a diagonal is from last week's lesson? What is a diagonal, Grayson? Very good. It connects two non-adjacent vertices. So two vertices that are not next to each other. Do you see how B is going all the way across the diagram to D? And A is going across the diagram to C? Now, the cool part, and that's part of our theorem, is that where those diagonals intersect will be the midpoint of both of them. So Z is the bisector. It's the bisector of both of those diagonals. So I now know that AZ is the same length as ZC. And I know that BZ is the same length as ZD. So the property here is that the diagonals of a parallelogram bisect each other. And if you don't remember what bisects means, right, just remember it cuts it in half. So each of these are cut in half. Any questions on any of these four theorems? Okay, that is all you are learning today. The rest is just going to be applying these theorems to examples, okay? So take a look at our first example. It does not say that ABCD is a parallelogram. Please write that in there. You have to be told that this figure is a parallelogram in order to use the theorems. Otherwise, it's just some random rinky-dink quadrilateral with no theorems, okay? But as soon as you see that it's a parallelogram, you can apply any of those first four theorems that we just learned. All right, we're going to do this example not by writing out everything, by using different colors on our diagram, okay? So let's start with number one. Let's do number one in black. Name all pairs of parallel sides or parallel lines. Nick? A, B, and C, D are parallel. Very good. How did Nick know that those two had to be parallel? John?
They're across from each other.
Very good. And what shape is this?
Parallelogram.
Parallelogram, okay? Now, there's two pairs. What else must be parallel? Yes? Excellent. BC and AD must also be parallel. Is there anything else that must be parallel here? Yep.
CE and AE.
CE and AE. Okay. I disagree though, because don't they intersect at E?
AC and BD.
AC and BD. Nope, those intersect at E.
Oh,
Are there any other parallel sides? No, those are the only ones, okay? So we're done with number one. Guys, jump to number three. We're going to save number two for last because number two is going to be a lot, okay? So, name all pairs of congruent segments. John. CE, AE, and BE, and ED. Very good. Those are diagonals. So E has to be the point, has to be the midpoint of each of the diagonals. So it cuts BD in half, and it cuts AC in half. Very good. There's two more pairs of congruent segments. What are they? Congruent. Yes, Sophia.
BC and AD.
Excellent. BC, we're going to label with 3, and AD. Excellent. What else? What's the last set? Isabella? BA and CD. Because remember, this was a parallelogram. What do we know about opposite sides in parallelograms? They're congruent as well as parallel, okay? All right, now for the real test. And you're going to need to be very careful here with the red one, okay? All pairs of congruent angles. Oh boy. There's like a ton of them. So let's get started. What is congruent here? Hayden. You have to use 3 letters to identify an angle. BC, which one? BCD, okay, is going to be congruent to what? DAB, that is one of them. Very good, Hayden. Anyone notice another pair of congruent angles? Go ahead, Sophia. Ooh, DCE and B, what?
BC.
No. DCE and BCE are not congruent. We don't know that the diagonals bisect the angles, okay? Yeah, Hannah?
DCE.
Okay, this one?
Yeah. And BAE.
Very good. Why are those two congruent? Hayden? Excellent. It's two parallel lines cut by a transversal, which is your diagonal. They're alternate interior. Very good. Juan? Very good. BEC and AED. Why are those two congruent? German? They're vertical. Very good. Anyone notice another pair? No, Scott. Yeah, Daniel.
BEA and CED.
I love it. BEA and DEC. We'll use 4 there. Dylan?
ABC and CDA.
Excellent. ABC and CDA. 1, 2, 3, 4, 5 congruence marks. 1, 2, 3, 4, 5. You guys, there's 3 more.
What?
Daniel.
There's 8.
CDE and ADE.
Okay, I'm going to use a different color because I'm running out of space for the congruence marks. Can you say those again?
CBE and ADE.
Very good. CDE and EBA?
Yeah.
Very good. 2 more. Anja. DAE, very good. ECB, very good. What's the last one, guys? Does anyone see it? It's kind of hard to tell. Yeah, Anja?
I think probably not, but
Go ahead, Anja.
the other side of it,
A,
we just
B,
did,
E,
like how it is on AMC.
A,
and C.
wait, no. It's CBE and
A, D.
ADE. I know. So this is why we saved that one for last, okay? I'm going to put red and green are all the angles, okay? Now, will I ask you to identify all of the congruent angles with a parallelogram with the diagonals given? No, okay? I will not ask you the problem that's this in-depth. But I could give you one angle and ask you, what's a congruent angle to that one? And I would expect you to be able to be like, oh, I know which angle would be congruent, and you could draw a line and figure it out, okay? Now, example 2 is more specific. It's going to give you individual parts of the parallelogram that it's asking you to find what its value is. So make sure that you're paying attention in example 2. Go ahead, okay? So we're going to try to find X, Y, A, and B in these parallelograms, okay? So take a look at example A. We've got a bunch of stuff filled in and other stuff that's missing. What could we figure out? We have X, we have Y, and we have B. How could we figure out any one of those? Cody? You want to figure out X? How do you know what X is? Good. It's going to be the same as U, which would be 80 degrees. I can put congruent symbols here and here. Excellent. What else could we figure out? We now have B and we have Y. Anja. Y is what? Very good. Why does Y have to be 100 degrees? Good. So 180 must be equal to X plus Y because they're supplementary. They're next to each other. So 180 must be equal to 80 plus Y. Subtract the 80 from both sides and you get 100 equals Y. Bless you. What else can we figure out? We have one more thing, which is B. Ronnie? Excellent. How did you know that B was just 9? RU is also 9. Very good. Okay. Yeah, Ronnie. T would also be 100. Very good. Okay. It didn't ask us for T, but we could also figure out T. Does anyone know what UT would be? 6. Okay. Any questions on this one? Pretty straightforward. Okay, let's see an example where we have the diagonal given. Now, X, guys, is referring to this angle right here, okay? Just that small top piece of that angle. Okay? No, I'm sorry. X is the whole thing. X is all of RSU. So from side S all the way to side U with the R being the vertice. Okay? All right, let's start. What do you guys want to start with? Because we have B, we have A, we have Y, and we have X to solve for. You want to solve for Y? What would Y be equal to? Good, it's 45. Why is Y 45 degrees? It's alternate interior. These two have to be congruent. Very good. So we got Y, we have X, A, and B. What is B? Excellent, because that's a diagonal across your parallelogram. So it's cut in half by the other diagonal. Excellent. What is A? 12. Now comes to the fun one. Can anyone figure out what X has to be? Hayden? It has to be 100. Why? Add 45 and 35 and you would get the measure of this whole angle, correct? What is the measure of it, Hayden? 80 degrees. You take away 80 from 180 and you get 100 because two angles that are next to each other in a parallelogram are supplementary, so they must add up to 180. Questions? Hannah?
Yeah, can you repeat that?
So, two angles in a parallelogram that are next to each other. Do you agree that these two are next to each other? They must be supplementary, correct? So they must total 180. We knew that this angle was 35 and 45 added together, which gave me 80. Take 80 away from 180 and you're left with 100 degrees. Okay? No, don't apologize. Never apologize. Any other questions, guys?
Wait,
Waiting.
so you add 45 and 35, which gives you 80.
Mhm.
What do you do after?
You take it away from 180. So we do 180 minus the 80 that was there, and that gives me 100. Because remember, angles that are next to each other in parallelograms, like directly next to each other, consecutive, they must be supplementary. So they must add up to 180. These are good questions. Any other questions on this example? Okay, last one. Sienna, what would you do here? Good. 4x needs to be equal to 8. Divide both sides by 4. X must be equal to 2. Very good. Christian, how would you solve for y?
You put it equal to 13.
Good. You say 3y plus 4 equals 13. Christian, how would you solve this?
You subtract 4 from 13.
Uh-huh.
And then divide by 3.
Divide by 3. What's y equal to, Anja? Y is equal to 3. Pretty standard, right? So anytime we have opposite sides, we know that they must be congruent, so we set them equal to each other. Dylan, you with me? Carson, how we doing? Good? So-so? Is anything confusing?
It's just I need more.
Yeah, more practice. Okay. Well, you're in luck, Carson. With 3 more examples, okay? Example 3. Find the perimeter of PINE. Guys, your symbol should look like a parallelogram symbol. So make sure that you fill in the parallelogram symbol, the italicized rectangle. It will not look like that symbol that's circled, okay? It will look like what's inside, okay? It'll have to have those slants on it. What do I do? What does Ms. Jericho always want to do? Draw a picture. What are my vertices? P, I, N, and E. Make sure as you go along your figure, you follow the order of the letters. So I went P, I, N, E. You can start with whatever vertex you want, but you have to follow your way around the figure, okay? You cannot do this. You cannot have like I over here, N over here, and E over here. Do you guys see the difference there? Okay, that's a big no-no. So make sure that you're following around your figure. Now you can put I down here, N over here, and E over here. You're still following it around. Doesn't matter where you start or which direction you go. Just make sure that they're in order, okay? It said PI was what? 12. And it said IN was what? 8. So does that help me? What else do I know about the figure? Nick? EN would also have to be equal to 12, and PE would also have to be equal to 8. Very good, Nick. And then how do you find the perimeter of a quadrilateral? You add them all together. So it would be 12 plus 12 plus 8 plus 8. 12 and 12 is 24 plus 16 gives me 40. So my perimeter is 40 units. So if you're ever given two sides of a parallelogram, you can figure out the other two, and now you know the perimeter. Okay, next example. Example 4. Find the values of x and y. Val, go for it. Set what equal to each other? 2x equal to 50. Why am I setting these equal to each other? Val is correct. Why do I set these equal to each other, German? They're opposite angles. Very good. And this is a parallelogram. Excellent. German, go ahead. You can divide both sides by 2. Val, what do I get for x? What? Okay, 25, and we put degrees on it. Mario, solve for y.
Set y plus 3 equal to 18.
Uh-huh. Why?
Because it's parallel.
Okay, what do we know about parallel sides in a parallelogram?
They're equal.
They're equal, they're congruent. Very good. What do I do?
Subtract 3. 15.
Y equals 15. Very good. Is that y? Does it need to have degrees on it? Why not? It's a side, not an angle. Okay. Did x need to have degrees on it? You betcha. Okay. We need to have degrees because we're talking about an angle. Any questions? Okay. Last example, people. 3 vertices of parallelogram W, X, Y, Z are W at -1, -3, X at -3, 2, and Z at 4, -4. Can you find the vertex Y? Well, let's figure it out. So let's go ahead and plot these. W's at -1, -3. So this is W. You don't have a graph? Oh. Can you guys add a graph really quick? I'll give you guys a few seconds. I wouldn't take a picture of mine because it's going to be blurry. Yeah, Grayson? Huh? Okay. What's up? Yes, you may. I think I have graphs in some of the other notes that you guys took. All right, so we're going to do the same thing. Hold on, hold your questions to the end. And we're going to start at Z and move the exact same way because it should be the same slope. Do you guys agree? So we're going to go up 1, 2, 3, 4, 5. So up 5. And then where do we go after that? To the left 2, correct? So -2. So this should hypothetically be the points of Y. Does it create a parallelogram?
Yes.
Bingo. What are the coordinates of that point? 2, 1. Let it sink in. Hannah, what's your question?
What if you went like the other way where you went right 2 and then up 5? Would that be wrong or correct?
That's also fine, okay? But if you go to the right 2 and up 5, I hope you mean right 2 and down 5, correct?
No.
Because right 2 and up 5 is going to be wrong. That's going to be over here.
No, look the other way. Oh wait, never mind. I don't do directions. I meant like under it.
You meant to the right 2 and then down 5?
No, the other way. Like you don't go above it. You go Like the other way.
Oh, like this? Go down 1 to the right 4? That's fine. That also works. You just have to pick one side, guys, and make sure that the other side is parallel to it. But you can use either of the two sides. So look, What if we started at W and went to Z? We would go down 1, right, to the right 5, correct? So -1 to the right 5. Let's go down 1 to the right 1, 2, 3, 4, 5. Are we at the same point?
Yeah, that's still not what I meant. I meant like going to, 3, no, that's not, yeah, 3, comma, 3, I mean, -2, comma, -3, and then going up.
-3 is right over here,
Yeah,
Hannah.
and then going up.
Oh, so to the left 2 first and then up 5?
Yeah.
Yes, but remember, you always put your rise component, the 5, over your run.
Yeah.
So your slope is 5 over -2 regardless, okay? Don't turn these in yet. I need you to answer these last 3 questions. I'm not going to discuss them. I don't want you discussing them with anyone. Do the best you can. Don't go back in your notes to answer them. If you don't know how to do it, just write, I'm not sure how to do this problem, and then turn these in. But give me an honest effort on these 3 for your complete this section of the notes.